Hi everyone, so my name is Sandeep and today we solve a problem in lead code which is a very easy problem, design hash map. So it is an easy problem but the concept behind it is very important. So let's see what is the problem and we will go through this. Okay, so the problem is we need to design a hash map. Okay, so in that hash map uh, we have a functionality of put. So here we have a key and value pair and we have to insert that key and value pair in the hash map. And if that key is already exist, so in that case we have to update the value. Okay, for that corresponding key we have to update the value. The another functionality is get. So if someone gives us the key, we can access the value. And if that key is not present in the hash map, we need to return -1. The next functionality is remove. In that we have one key and we have to remove it from the hash map. Now the flow of problem is first we understand what is hash map. Okay, because there are some beginners, so for that we have to understand what is hash map. So hash map is also a data structure which we use in order to store the values, right? In hash map we basically have a key value pair. Okay, what do you mean by key value pair? Like ram, and this is a key and its value is a boy. Okay, or it can be anything. This can be string, this can be integer, this can be string integer. The key and value can be anything. Okay, and in the hash map we are storing values like this, key and value. Okay, if someone want to access the value of ram, they simply said uh, the hash map value for ram and it will returns boy. Okay, and if we need to update this with girl, so simply we need to say hash map ram, which is a key and its new value is girl, and this data structure automatically update its value with the girl. Okay, so the first question is what is hash map. So hash map is a data structure where we are storing the values in such manner. Okay, the next question is what is the benefits of hash map. Okay, why we use hash map? Because we have other data structures like array. Then why we don't use array, why we need hash map? Let's understand this one. In hash map we have functionalities like insert, access and remove. These are the functionalities we have in hash map, right? And these things we can also do in array. What is happening in array? Let's suppose this is my array, right? And if I need to insert 10 in it, how we can insert? Simply we are just saying array dot append 10 and this value is stored somewhere, right? And the time complexity for inserting this 10 is big of when, right? It's simply like when we are saying array dot append, it simply check the empty space in the array and put that value inside the array. But when when we want to access that value, let's suppose if I say give me 10 which is present in this array, in that case we have to iterate or we have to go through this whole array and find this value 10 and return back. In that case the time complexity is big of n. Okay, and if the array size is 10 to the power 6 or more than that, then the time required is very high. Due to this problem, we are using Hashmap. What Hashmap does? So, as we know, if we have an array and if we know like this is the value 10, and let's suppose this is some address, okay, this is the index, this is 0th index, 1 index, 2 index, 3 index, 4th index, 5th index, right? And if someone asks me where is the value 10 or give me value 10, and let's suppose somewhere I come to know that my 10 is stored at index 0. In that case, I don't have to go through this array and find the value 10. I can simply go to this 0th index and access this array. And that's how we are going to access the element in big O of 1 time complexity. And this is what the hash map does for us. And that's why we are using hash map due to its less time complexity in inserting, accessing and removing the element. Great. Now for that we need to understand the next thing, which is working. What do you mean by working? Working is how these hash maps are working. So as you know, we have a key, and for that key there is a corresponding value we are going to store. Okay, and I also tell you, to getting or accessing the value we need some mechanism which gives some index. Okay, which gives some index. So basically we have an array, right? Let me create it, and for some index we have some mechanism, and that mechanism gives us the index, and with the help of this mechanism we can simply go to that index and insert the value, access the value, or we can remove the value. Okay, so this mechanism is nothing but a hash function. So this is nothing but a hash function. With the help of this hash function we get this index, and using that index we can easily go and insert, access or remove the values. Great. Now let's talk about what is this hash function. Let's talk about this hash function. Okay. Now this hash function is made up of two things. Okay. The first thing is there is a hash code generator, and there is another part is compression function. Okay, the another is compression function. Let me describe this. So let's suppose we have an array, and in hash map this array is called as bucket array. Okay, so this array is called as bucket array. Okay, and let's suppose the size of this is 30. Okay, so what happens, we have some key. Let's suppose my key is A, B and C. Let's suppose this key is going through my hash code generator and I am getting an index, and that index is 2000 or 200, right? In that case that 200 index is not present in this bucket array because we have the index from 0 to 29, right? Then we can't able to put or insert the value in it. In order to maintain this index according to the size of this bucket array, we use this compress function. Okay, And compress function is nothing but it is just a modulo of whatever the size of this bucket, which is 30. And when we do this, this function gives us the value from 0 to 29 always. Okay, and that's how we can easily find the address and insert the value in it. Great. Now let's understand what how this hash code generator works. Okay, so let's talk about the hash code generator. So hash code generator, right? Now what is happening in the hash code generator? As I tell you, we have a key, we are passing this through some function, and we are getting the code, which is nothing but a hash code. Now there are various ways to convert this key into hash code. The one simple way is, if let's suppose my key is ABC, so all these string ASCII value, so we can do ASCII value of A, add ASCII value of B, add ASCII value of C, and we are getting some integer value, let's suppose 24, right? But there is one problem with this approach. If we do BCA, its ASCII value is also 24, and if we do CBA, its ASCII value is also 24. In that case, we are not considering this way. The another is, if let's suppose we have key is ABC, we can do like 10 to the power 0 into ASCII value of A, plus for B 10 to the power 1 into ASCII value of B, plus 10 to the power 2 into ASCII value of C, right? In that way we are getting some integer value which is different for ACB, right, and which is different for CBA, right? And after getting this hash code, we are going to use compress function. Okay, why we do this? In order to make this hash code same for the array size. If array size is 20 and the hash code we are getting is 2000, in that case we have to maintain this according to this. Okay. Okay, now there is one more thing we need to understand. Okay, very important things are there. I think till now everything is clear. If not, you can go back to the video and see it again. Okay, so let's take some scenario to understand the problem. So let's suppose this is my bucket. Okay, 0 1 2 3 4 and 5, somewhere like this. Okay, and so on. Now let's suppose we have a key which is ABC, and we have a key which is DEF. Okay, we pass this through hash function, and we are getting, let's suppose, 105, and here 205, let's suppose. Okay, and my bucket size is, let's suppose, 5. In that case, if we do compress functionality, so here we are getting 5, sorry, if we modulo it with 20, here we are getting 5, and here, sorry for this. So what I said, let's suppose here I am get 5, here I am getting 205, and if I do modulo 20, I am getting 5, and if I do modulo 20, I am getting 5. In that case, this ABC is pointing to this index, and this DEF is also pointing to this index. So at the same time, these are the two different keys which pointing to the same index, and that case is nothing but collision. So this is called as collision in hashmap. Okay, when two different keys specifies the same index. Okay, so in order to handle this collision, we are basically use another approach, and that approach is called as linked list. Like we are using the linked list, okay, in order to handle this collision. How we do this? Let's understand this very carefully. So let's suppose this is my hash map, sorry, array. Let me give some indexing, right? And let's suppose there is a key which is ABC, and I am getting 4 as an index. So in all these cases, we are basically put some head. This is a head node, this is a head node, this is a head node, this is a head node for the linked list. Okay, it means at each index we are putting a node, and this node in starting is none. Okay, this node is in starting is none, so everyone contains none as the value. So initially we have a key as a 4, sorry, ABC, and the index we are getting 4. So I go to this index and I check it is none or not. So it is none, and if it is none, what we will do? If it is none, we simply go here and create a linked list node and put A, B, C, right? Now let's suppose next key comes in, which is D, E, F, right? In that case, we also get the same index. We also get the same index, which is 4. Then we again go to this index and check whether it is none. No, it contains some value. In that case, we take this node and go until the last node. So we reach at this point and attach one more node to that linked list, which is D, E, F, and that's how we are storing value in this array with the help of linked list in order to avoid collisions. Okay, now it is a long concept, but it is like necessary to understand. Okay, now there is one more problem you face. Okay, let me explain that problem. Okay, got it. So let's suppose in the worst case, okay, in the worst case what happen, there is, let's suppose, 1000 values which is pointing to this fourth index, and we have 1000 nodes over here. Then in order to access any key or any key from there, what happens, we it will take a lot of time. If let's suppose let's suppose we have n keys we have to store in our hash map, and all that keys, let's suppose, specifies to the fourth index. Then in order to access any element, in order to remove any element, the time complexity is big of n. In that case, the reason why we use hash map, okay, the reason why we use hash map is going into vain. Okay, so this problem, in order to handle this problem, we are using one terminology which is called as load factor, which is called as a low factor. According to this, whatever the size of our bucket and whatever the count of nodes or the count of element present in it, If we divide this and its value means the total number of nodes in this array divided by the size of the bucket, if it is greater than equal to 0.7, in that case whatever the size of this bucket, we will going to increase its size by 2. It means if its size is 6, then we create a new array and that array size is 12, and we will take all these values and copy in that new array, and this process is called as rehash. This process is called as rehash. Okay, so these are all the concepts, right? These are all the concepts we are going to use in order to implement our hash map. Okay, I think it is very like little bit lot of things there, but there are a lot of concepts to learn, which is very important. So let's go to the code. Okay, let's go through the code and understanding things. I solved it in very last like 4 months ago. Let's understand this. So initially, sorry, initially we have to put, we have this key and we have this value. So there is inbuilt, there is a inbuilt function in Python which is a hash, and okay, let me take this now. Okay, so this inbuilt hash gives us the hash code. Okay, so it basically do all that things that I tell you, and it gives us a hash code. Now according to this hash code, what we do, we are compressing it according to the size of the bucket, and it will gives me, it will give me the index. Okay, let's see. This is self dot bucket index, and it will simply do modulo according to the bucket size, and it will give me the index. Okay, after that we will check for that index. If we will take the node, we will check if that node is none, it means there is nothing there, and we are going to add that. At that node we are going to create a linked list node, and that node is put in that index. Okay, and otherwise if head is not none, in that case we are going inside that linked list until we are getting the head value as none, and then after that we are going to insert one more node. Got it? Now this is the new node which is inserting at that index, and after adding a new node we have one more thing which is a count. Okay, and that count does nothing, it simply calculates the number of nodes we are stored inside the array. So whenever we are putting some value inside that array, we are going to increment it. Okay, and as I tell you, there is a load factor, and how we, so how we calculate the load factor. For that we have a count and we have a bucket size, we will divide it and we are getting the load factor. And this load factor, if it is greater than 0.7, we are doing rehashing. Rehashing means increase the size of array by 2 and also copy all the values. Okay, let me show you. So this is the rehash. In that we will increase the size by 2 and copy all the elements again. Okay, and again make the count as 0 for the new array. This is how we are putting the elements. Now if someone gives us a key, for that we need to find the index. Okay, and we have to go to the same thing because the index is at the same point, right? And one more thing in order to understand, let's suppose this is the hash map, right? And at this point there is a one linked list node. It contains A, B, C, and there is one more linked list which is D, E, F. And someone says check whether this key is present in this hash map. So this is index number 2. In that case, we need to go through all the nodes one by one and check whether the key value is equal to that key that we want. Let's suppose this is DEF and this is ABC, so we are not going to return the value for that. This is DEF and this is DEF, then we have to return the corresponding value for that, right? That is what I am doing here. In the get, we simply check if the node dot key is equal to the key that we want, then we return the value for that. And if it is not there, we are going to return -1. And in order to remove it, we simply what we do, we simply, let's suppose we have to remove DEF, so we simply remove this connection and make it next as none, and we remove this connection. That is what. And after removing this, we also have to decrement the count, right? That is the way. And if we are not finding that key which we want to remove, for that we need to return -1, that it is not present there. Okay, let me go and run this code for you. So it works very fine. I hope you like all the concepts that we learned today, and I will try to create more videos. If you like it, please like, share, and subscribe, and please comment out so that I will be motivated and create more content for you. And thank you. Have a nice day.